Right, this is the video for the Solving Quadratics unit review number 1. There's 2 reviews. I'm going to do some problems on both. The first one here says solve each of the following quadratics by factoring. So show all work. When you solve any quadratic, you need to start by making sure that the quadratic is set equal to 0. Now, in number 2, the quadratic is not set equal to 0, so we need to start by adding 40x to both sides. All right, these are not like terms because I have an x squared and an x. So I'm just going to write them next to each other. 48x squared plus 40x equals 0. Now, I have 2 terms here. I can't take the square root, but the first thing I have to do every time I factor is look for a GCF. I do have a GCF here of 8x. So I'm going to pull an 8x out in front. And what I'm left with in the parentheses is going to be 6x plus 5. Now that I'm in factored form, what I do is I have to use the zero product law, which says that I take each factor and set it equal to 0. Every factor with an x. So here I'm going to take 8x and set it equal to 0, and take 6x plus 5 and set it equal to 0. Now I solve each of those mini equations for x in order to get my solutions. So on the left I divide by 8. I get x equals 0. That is one root or a solution. X equals 0. The other one here I subtract 5. I get 6x equals negative 5 and divide by 6. So my other root is negative 5 over 6. Typically for a quadratic we have 2 answers. So we have 0 and negative 5 over 6 for number 2. For number 3 here, I have 2 terms again. I'm set equal to 0. This one, I'm going to use difference of squares. There's no GCF, but I can take the square root of x squared, which is x, and the square root of 225, which is 15. I can use this method because I have a minus sign in between the 2 terms. Now, factored form here takes the x minus 15, and then the other parenthesis is x plus 15. To solve, I now just take both of those factors and set them equal to 0. Now I'm going to solve this quadratic, the one on the left, I solve by adding 15. And I get one solution is that x equals 15. That's one solution or x-intercept. And then over here, I subtract 15 and get that the other solution is negative 15. All right, so that's a review of factor to solve. The next one, I'm going to review just simplifying square roots since we're going to use those in the quadratic formula and complete the square. Now, when you simplify square roots, you need to know the list of perfect squares. All right. Now, when you look at those, you need to find the biggest number from that list that goes into 120. And it turns out to be 4. It's going to be 4 times 30. So we rewrite this as radical 4 times radical 30. That's the same as radical 120. Radical 30 does not break down, but radical 4 does, and radical 4 is equal to 2. That is the most simplified form that you have. You can check that by typing it into Desmos. We've done that before. We've taken our calculator, we go into Desmos, and we can type in square root of 120. That was our original. We get 10.95. And we can type in 2 radical 30. I get the same answer, so I know that I simplified correctly. All right. Now, square root of negative 98. I have a negative, which means that I'm going to have I in my answer. So when you have I in your answer, you need to at least pull out a square root of negative 1. Now, 98 is when I break down perfect squares. That's radical 49 times radical 2. Radical 2 is the only one here that does not change. However, the square root of negative 1 is I, and the square root of 49 is 7. So this simplifies to 7i radical 2. All right, now that we reviewed a little bit of simplifying square roots, let's use those in solving here. Now the first problem we're going to solve by graphing. All we have to do to solve by graphing is make sure you're set equal to 0, which we are, and we're going to type that quadratic into Desmos, or your calculator, to find the root. So we suggested Desmos. All right, so we go back to Desmos here. We're going to type in negative x squared minus 4x plus 1. And I have my graph here. Now, when I click on the roots, this is what I get. Okay, so I'll take a second. I want you to pause the video. I want you to write down those answers. All right, so we have our two answers. Now, those do not look very nice. They don't look rational. So since they're not rational, they're irrational, which means if I have irrational roots, I cannot factor my quadratic. All right, a couple more here. Let's skip to now Quadratic Formula, which is up here in the box in the top right of the screen. In order to use my quadratic formula, first your quadratic has to be set equal to 0, which we have. You need to know what a, b, and c are. A is the coefficient in front of the x squared, b is the term in front of the x, and c is the constant. Now we take those values and we put them into our quadratic formula. So we start with x equals. Now we have the opposite of b. b is positive 10. The opposite of that is negative 10. Plus or minus one giant square root. Now under the square root, we put 10 in parentheses, so b squared. Then it says minus 4 times a, which is 5, c, which is 5. And all of that, including the negative 10, goes over 2 times a. Now we get to simplify this. The negative 10 stays the same with a plus or minus. Now your job is, we're going to use Desmos, or your calculator. You're going to put what's under the square root, called the radicand, just into Desmos. Do not type the square root, just type the 10 squared minus 4 times 5 times 5. So we'll come in here, we'll have, for your parentheses, 10 squared minus 4 times 5 times 5, which gives me 0 actually. So what's under the radical is 0. So we have negative 10 plus or minus the square root of 0 all over 2 times 5, which is 10. Now, the square root of 0 is 0. So I have negative 10 plus or minus 0 over 10. Now, normally, and I'll write this out the long way, if I get rid of the radical, I need to get 2 answers. Here I have negative 10 plus 0 over 10, and negative 10 plus 0 is negative 10 over 10 is negative 1. And same thing down here, negative 10 minus 0 over 10. Well, we actually end up getting the same answer. So my solutions are just x equals negative 1. And you can write it twice if you want to. But remember, when you get rid of the radical, you need to give me 2 rational answers if there's no radical left. The other problem here, number 12, will have a radical in the answer. You can leave the radical. Because I have rational roots, yes, this quadratic is factorable. All right, I believe the next one is the last one on the review. Let's see. Yes, number 14, we're going to use completing the square. In order to use complete the square, again, we start by making sure the quadratic is set equal to 0, which it is. In order to use complete the square also, the leading term, coefficient, has to be 1, which we do have here. So we can complete the square. To start, we add 4 to both sides. When I do that, the x squared plus 12x stays the same. I fill in that spot where the 4 was by adding a box. The other side is equal to 4 plus a box on that side as well. We need to balance the equation. To fill in the box, you take half of the middle term. So half of 12 and square it. Half of 12 is 6, and 6 squared is 36. So I put 36 in both boxes. Now you're going to combine. On the right-hand side, 4 plus 36 is 40. The left-hand side factors. Remember, this is a perfect square trinomial, so we had a shortcut. Inside our parentheses will always be an x. And then to fill in the number part, remember you take half of the middle term. And half of 12 is positive 6. So I'll do a plus 6 in both parentheses. That's our shortcut. You could just split the middle if you don't trust me, but that's the shortcut. Now what I would do is condense the left-hand side. X plus 6 squared equals 40. Now we're going to solve for x. We're going to take the square root, which gives me x plus 6 equals, now with the square root, we write plus or minus the square root of 40. Now one thing to remember is when we have to check to see if I can simplify the square root of 40. I actually can here. The perfect square that goes into 40 is radical 4 times radical 10. And that simplifies to be 2 radical 10. So I'm going to take that 2 radical 10 and replace it with the plus or minus 40. So what you actually have here is x plus 6 equals plus or minus 2 radical 10, right? We want those, ooh, I didn't need to do that. That's a highlight. All right, we're having trouble writing this one today. All right, there we go. So those are all equal. I just replaced it. Last step here is to subtract 6. When I subtract 6, it goes in front of the plus or minus, and your final answer is negative 6 plus or minus 2 radical 10. That is what goes on the line for solution. X equals negative 6 plus or minus 2 radical 10. Now those are irrational roots, so you could not have factored this quadratic. If you're feeling really confident after this review, you can go ahead and take your unit test. If you feel like you need more practice, there is a second review. Go ahead and give that a try and ask your teacher for help.